Hello everyone. Today I'll talk about the solution to the problem parsing a Boolean expression. Well, it's unfortunate, problems like this happen sometimes. At least in this case the implementation won't be that bad. And also we have this nice property that every token that we have consists of exactly one character. So we have values in the form of t or f, so a single character. Operators are negation and or, one character. And also there are parentheses. And there are also commas, though those commas essentially don't matter at all. Of course, we have to evaluate this expression, and typically when you are parsing and you don't have access to some parser library and you don't want to implement a separate, multi-step parsing, so essentially first a lexer, the tokenizer to create a tree, because when you create a tree, then you can very easily evaluate an expression, but typically it's something that you don't want to do in situations like this, where this is a single task with a very simple grammar. And in many cases, either a recursive or a stack-based approach, which typically are the same thing, is sufficient. And luckily it's sufficient here. So I recommend that we start with a stack. On our stack we'll have some sentry, but it doesn't matter in this problem, because if the whole expression is correct, is valid, follows the given rules, then this is a guarantee. Then we don't need that sentinel, but it also doesn't hurt. And now we'll be parsing our expression from left to right and maintaining on our stack a simplified form of everything that we've seen previously. So if we have something that we can essentially calculate, so most specifically this is about parentheses, so when you see a closing parentheses, then we can already calculate everything that this parentheses relates to, because we've had the operator, we've had the opening parentheses, some things in the middle and the closing parentheses. So as soon as we see a closing parentheses, then we want to evaluate everything that it corresponds to. So we ignore commas, they don't matter. Again, it's possible to separate all the characters in the input into separate tokens even without those commas. T and F are true and false, so that's what we push on the stack if we see them. We also push on the stack opening parentheses, so this falls into this else clause, because we want to know, of course, where the opening parenthesis is. And our simplifications occur whenever we have a closing parenthesis, because, and that's what I mentioned before, we now have to remember all the operands within our operation, so we'll remember them in the L list, and we have to gather all those operands until we reach the opening parentheses. So in essence, when we see a closing parenthesis, then we get this sub-expression, this, and then we reach an opening parenthesis, so we break. We get them into a list, then we eat up the opening parenthesis, and then the previous character is the operator, not and or. For AND, we have the built-in function all. For OR, we have the built-in function any. So they will do exactly what we need to do on our list of operands. Of course, if it's negation, then our list has only a single value, so you can just pop that value, negate it. And we have to remember that, since this is just a simplification of this expression, we have to push the result back on the stack. And at the end, we can return the last value on the stack, which is the final result of all the simplifications, so of performing all the operations. So luckily, this parsing problem was not that difficult.